fabricated, pre-finished volumetric construction. The new term for PPVC is DFMA, Design for Manufacturing and Assembly. And that's what you should be designing at. The design for DFMA is at the philosophy and the design inception stage of a project. So you want to study design, you want to start from DFMA. Why? You select the material, you select the component, you design the component that you can manufacture into PPVC, and then from there it's volumetric, you assemble from a single component, a rod, a steel, or a piece of plywood. You develop into a 2D version. 2D means you actually assemble part of the panel, and then you assemble the panel together and make it into 3D, which is volume, which is about like that. So that's the first technology, PPVC. Second one is what you're looking at standing in front here, the smart modular home. Now, why you want to do smart home? Not the IT smart home, smart innovation. Why? Because you and I all are growing up. Population growing. One day you get married, your generation and generation, more and more people, the population grow. But the demand of houses, the houses not built fast enough. You go to Cambodia, not enough house. You go to Thailand, you go to Indonesia, you go to any part of the world, Hong Kong, even Singapore, you wait for HDB flat 3 years, 2 years. Not enough home for you guys. So this home were built for them to stay quickly. Of course, Singapore contact high-end. So I'll show you the first technology, which is the connection system. And then this is a smart home, where you can see. Later I will show you how we actually open and close. If you look at the diagram here, you look at here. You look at here. When it is closed, you look at the dotted line, it's all closed up, right? And it becomes like that. So you transport the unit in this manner, right? And when you open up, then you can have your dining area, living area. It's open up. You open up, you see like that. So you walk inside, you can see the bedroom, the kitchen, the toilet, and you have a nice study room where you can do your computer work. So you can see the study room here, and you have a bed here, you have a toilet, the kitchen, and the living area. It's better than a condominium, the luxury inside here. Like condominium, a lot of waste space. This one compact, and you don't pay for a fraction of price. So this is where we are marketing. So this is the first technology, and the next one is the connection. When you want to build high-rise, engineering student, are you an engineering student? Yes. How you design the joint? Steel. You got to connect the top and bottom. What do you have? Tension, compression. Then you put together all the buildings so broad. You have the lateral tie, lateral forces, movement, earthquake, wind load, shake, tie back, movement, human load, dynamic load. So you have a lot of loads calculation to do. So therefore, you have the lateral tie and vertical tie. What is you call this? Connection. So I invented the connection, and now it's been used, it's been widely used and penetrating the world. So I've done a few projects with the connection, and you learn about it and see. If you can do a better connection, please give me a call. I will adopt and I'll pay you. I pay you handsomely. Okay, take a look. Quick, because you're... How you connect them? Top and bottom, top and bottom. So we study about engineering, multi-story, lateral, vertical tie, very important. So these are ties. How you tie them? two together, the plate will tie together. This is the tie. First of all, there is a transfer slab, the foundation. And the foundation, you actually put this into the foundation, embed it, and tighten to the foundation to stabilize the building. In order to do PPVC, you got to be very level, perfect level. And then you put the column on. This represents the corner of this box. The corner of this box, one of these. Better something. No, put this one over here. Yeah. Okay, so then you use a pin. There's a long pin. A long pin like that. The height of the unit, longer than the unit. Okay, then this is vertical tension and compression. Then put a tie plate. The tie plate will tie the two together. Imagine you got another one here. The two together, you can't split them anymore. You can't split them. Okay? Then you put the next column, the next unit on top. Okay, so the next unit on top, all this is perfect, vertical, 2 mm tolerance, precision. Then you tighten the next unit. Just tighten it. But why stainless steel? Because the authority, BC asks you, if you use normal mild steel, how do you prevent corrosion? What if the joint corroded and failed, the building collapsed? 40-story failed, boom, down. No, don't play a fool. Corrosion, very important. Then also we have sacrificial thickness. Corrosion, we allow corrosion to happen. We give 5 mm thicker so that the glass eat into it, you will not eat the structure. So it's still strong. We study the statistic of corrosion. For stainless steel, maybe 1 mm maybe take you 5 years, 10 years, or 20 years. In this case, about 20 years. So 1 mm, 20 years, 5 mm, 100 years, 99 years, you are not around anymore. You know what I mean? So, okay, this is about the connection. Designing the connection you send to me, I pay you. But not good enough. You must be able to do it fast, quick. We talk about productivity. We do a special joint, a special lifting lug. Look, just like hook to the sling. You just take this one, put it in, and then turn. When the flap goes down, it is locked. You can't open up anymore. No matter how, this is designed to 10 ton. The unit is only 5 ton. 5 ton at one corner, 20 ton, no problem. 4 lugs, 40 ton, can lift. Engineering smart student, you can calculate this. Right? Lift it up. Very fast. From the ground to the 10th story to the 15th story, very fast. And up, boom. 15 minutes I finish, I come down. But if I install one unit in 15 minutes, in 1 hour I can install 4 units. 4 units, that's a lot. In 1 hour, in 10 hours I install 40 units, the whole condominium finished already almost. Right, so that's called fast construction, high productivity. High, you save time, you save labor. You see here, we design DFMA to this, flat pack to here. We have safety, serviceability, environmental, transport, logistics saving, factory maneuvering, handling, efficiency, the construction operation, quality, maintenance, demolition. When you demolish, you just take out this, dismantle everything. You don't have to scrap the material, you recycle the material. That is sustainability. Then you have efficiently install 1,408 square meters a day. That's 14,000 square feet. Oh, crazy, man. In 2 days, I installed 14,000 square feet. Can you build a house 14,000 square feet? Wow. How much a flat? 1,000 square feet only. I can build 14 flats already, right? 14,000 square feet. Our HDB flat 1,000. Wow, 4-bedroom, very nice, right? There are 14 flats we do in 2 days. So this is how fast it is. By flat pack, we don't ship volume. We save from 22% to 8% of freight costs. Then next thing, the manpower we reduce by 40%. I don't need so many workers. Only the 10 this side can do enough already. The rest can go home and sleep. Right. Next, productivity 40%. This 4% produce 14,000 square meter of land of space installed in 2 days. Amazing, right? The high productivity. We don't need to employ. We don't need to employ so many foreign workers. So your neighbors don't disturb you. No cultural problem. Don't say that, don't put me. But that's fun, right? Okay, then you have time saving, 40%. See? 40%, 1 day or 10 hours. How do you do it? Let's do it 6 hours. I save 40%. 6 hours I can go and have a happy hour and drink. So that's how you save time. So that's how you work. And that's about our connection system, our lifting system. Okay, finish. Show you this one, how we actually close and open. So you ship the unit like that. When you go outside, open up, it's not space. But you save freight cost, you save transportation. If I open up, I cannot transport it on the road, right? Too big, right? Okay, open up.
So I'll start with the green first. You know how steel is made in Singapore? I will explain. Assuming this old building, end of life, demolish, take out all the scrap, the steel scrap, and then this goes to net steel for recycling. We melt it. After melting, we make reinforcement bars. Then from here, it goes back into construction again. So end of life, this building demolished again, scrap enters net steel, so this process repeated. There's a very sustainable way of making steel right in Singapore. So Singapore generates a lot of scrap, and what we need is only a certain portion of it. So it's a very sustainable construction. So in Singapore, the green is measured by number of green ticks. In the refrigerator, you have seen the ticks, right? Number of ticks. So for green also there are ticks. So net steel products are actually 4 ticks maximum. So now we're going through the reinforcements part. So we make upstream products and downstream solutions. So when we say upstream products, there are basically 2 types. One is bar in straight form. Another one is coil form, bar in coil form. So this is the bar, and we make to various country specification. So you can see Singapore standard. You come across this standard, SS560, right? So SS560, we make the normal steel, normal grade 500B, and also the high strength grade 600B. This is a new steel in Singapore, high strength steel. So apart from that, we make steel for various country specifications. So it goes as far as Canada and the Asia Pacific, Australia, New Zealand, and ASEAN region. So that's our upstream product. So from this, then we make our downstream solutions. So downstream is actually fabrication of the bars. So we make carpet reinforcement. So this is in a roll form, rebar in a roll form. So you know the floor carpet you roll out. So similar to that, you roll out the steel carpet, forming the reinforcement for the slab. And these are cages for both pile, column, beam, and this is a coupler. It's like a nut and bolt to join 2 pieces of rebar. So these are high strength grade 600 steel. These are different case study videos. I don't know how much time we have. Here's your tour guide. Okay, never mind, we skip this part. So digital is a new thing in Singapore. We're using three-dimensional rebar modeling or detailing. So before we fabricate, we must model this reinforcement according to the building's requirement. So this is a video to show how the reinforcement is inside the building. So this is a column, a beam, and a slab. So you can see all the reinforcements are modeled. So this is as per the structural engineer's design. So all the reinforcements are inside, modeled. Then any clashes, everything can be seen right now. Anything wrong, we can just correct it before construction. So this model is then used by the contractor to order reinforcement for construction. So you can choose, I want to order these 3 columns and this area of beam and slab. So that information will be extracted and sent to NetSteel. Then we fabricate and deliver to the site. So this is a digital ordering. I show you how the contractor normally places the order for reinforcement. So this is an underground building. The reinforcement is already modeled inside there. So the contractor chooses that portion of reinforcement to be ordered for his construction. So once he chooses a reinforcement, then he creates an order. The screen opens up, then he keys his information, like what's the delivery date and the purchase order number, all this information. And then he chooses the area of reinforcement he wants to order. Then all the reinforcement information flows into the system. And if you want to check, he clicks on the reinforcement bar, then the shape of the reinforcement bar, everything can be seen. That's an L-shaped bar. So once everything is okay, then the order is submitted by the contractor. And this information then will come to our system, and then we fabricate and deliver to the site. Any questions so far? Very clear? And you can also see which levels are already constructed. This is more of project management. So the blue means it's already completed. This is ongoing construction. So this way you can visually see the progress of building construction. So each cycle, each floor normally takes about 7 days to 10 days depending on the building size to construct. In this video you can see this building. I think everybody will be familiar. It's called the Marina Bay Financial Center. It's just nearby us. So we show you how this building was constructed using the prefabricated method. So this is a pre-cage column. It was fabricated in the factory, then delivered to the site. So they can hoist up. So made in factory, delivered to the site. And this is how we have machines to make these cages. So the 3D model information is useful for this fabrication. So the worker knows how to fabricate this. So these are completed cages. One cage can weigh about 2,000 to 10,000 kilograms. It's very heavy. So basically it's using prefabricated to reduce the construction time. Because if the workers have to fix the reinforcement one by one on site, it takes very long time. But since it's in prefab form, they just install it and then pour concrete. So it's much faster for them. So you can save overall 3 to 4 months of construction time. So that's a lot of productivity gain. So this is the order information. Once the contractor places the order, that information comes to us. If you fabricate on site, then if it's raining, they have to stop work. So all these are actually benefits to the contractor. Thus, the cage ready on trailer goes to site, they just wash it up and then they install it. And that's how they save a lot of time in construction. Also, they have no space, especially you're building in a city area, you don't have much space for fabrication on site. So basically they will need this kind of prefab solutions. I think the video is ending very soon.
I'm David, that's my team, we are group. It's Lucas and Laura, and we were welcome to our booth. We are a company from Switzerland and we are specialists in timber structure. And sorry about, we have just a small presentation on our laptop, not on the screen, but I hope everybody can have a look on the laptop. So we exist since 140 years. We celebrate this year 140. So I'm the 5th generation of this company. And it's a family-owned company in Switzerland, based in Switzerland, but we have also some one factory in China, and we have around 150 engineers, technicians, and timber specialists. So what's exactly what we do? So we are not a sawmill; we are also a producer of glue lamp. Maybe you don't know what glue lamp is. It's very easy. You have different boards, you can lamellas, and then you glue it together with a press. Then you can glue it straight, then you have a straight beam, or you can also curve. If you have a template, then you can let it for 1 or 2 hours, and then you have this curved beam, and then you can also do twisted. So we did in the past some good reference or some good construction. Maybe Lucas, you want to say some words about this?
Woolen structures, we can use it for making large span structures. So this is a good example of the capacity of a timber structure. This is called a dome. The shape is geodesic, so all beams have the same curvature. They are double curved. It means the shape is, in this case, the roof cover will be twisted. Here we have a mock-up from a 120-meter dome. That's what was built in Switzerland. That's a picture on the back. With this type of structure, you can go up to another 80 to 200 meters. This is clear span. One thing that is for you probably would be interesting is this was built, the structure was built in 6 weeks. It's 120 meters. If you have a steel structure or a concrete structure to do something similar, it would take compartments. Because we are able to do it without any scaffolding underneath. So it's a free, self-supported structure. But concrete cannot do it. Even if you have a precast concrete to assemble something like this, you need to have a structure underneath to support scaffolding to support. So that was the example from home. Here it's an example from a structure built in Korea. That's for the military. This is interesting because of the span. It's 80 meters free span. So the advantage of an arch structure is that you can make large spans. With a timber structure, an arch like this, you can go eventually to 120 meters span. If necessary, we can combine two beams or more. So we have a wider beam and we can make it a wider span. Here it's a free curved arch for a train station in Bern, Switzerland. The beam is making two curvatures on the same beam. Multi-family houses or office can be a solution. In this case, for you see here in Singapore, we have high-rise towers. Timber can go up to 90 meters height. That's about 30 floors. So it's cannot go so high as a steel structure, steel tower, but it's possible to do with timber, and it's faster than if you go with a concrete or with a steel structure. The advantage is also on the foundations. Timber is much lighter, 5 times lighter than concrete. Concrete is 25,000, steel it's even more. So it allows the concrete foundations to be much lighter than it would be with another type of structure. So this is examples. You have McDonald's, you have sports halls, research centers. The dome here is a picture of the dome before, the 120 meter. This can be used for industrial purpose, for sports. You can have a football field inside and at the same time have 30,000-40,000 seats. So it's possible for a football arena. That's a double curved structure. This was done in England, Cornwall. That's for the Eden project. So it's a bio-garden environment with several domes where this is the core building for the service. The wave structure that was on the previous picture. This is also in England. That's Crossrail. It's the new train stations, the new line of trains in London. Here we have the grid structure. This is also possible to work as a free-form structure. The shape can be flexible, so you can have a bionic design that it will be possible to do with a timber structure. For reference, in the past, that's a building built in Bern. That's for an ice rink with 90 meters span. It's an arch where you have a steel rod underneath, making the arch like this, but keeping the forces just vertical on the supports. The timber structure, at the end, it's 50 years old without maintenance. We have done 5 years ago maintenance on the roof cover. That was with the panel, the steel panel, but underneath you don't have any maintenance on the timber structure. So the timber structure can last more than 50 years without maintenance. Then you have a high humidity environment inside. That's another example. Here the roof cover is in timber. So this is more recent, that's just 40 years. The building itself is also without maintenance on the timber structure and the roof cover. 140 meters span. We have the terminal, the latest terminal here in Singapore that was opened with a structure that looks more or less like this. So it's not only possible with steel. You can do it in the future. You can do it with timber. We have done it 20 years ago, and now here in Singapore you have a steel structure that is more or less similar. So it's possible to do it. It was possible to do it in the past, and it's possible to do it in the future with larger spans. Bridges, that's for tanks, that's for a military bridge with 40 tons, for 40 tons. And modular construction for family and two-story houses, schools, and other public buildings like hospitals. Hotels are also a solution that can use this type. This was one of our last slides, but this was the first timber structure made in Asia, IS. In this case, it was for the Olympics in 2003 in China. After that, we have established a partnership in China, and we have a factory producing glulam structures in China. That's more or less what we have to show. That's an example of temples in China, and this is the last project we have built in China, and our team is still working on a second structure in this facility. That's for the military in China. Thank you for your visit.
Thank you.
You have questions? Then still you would have to protect the steel structure from the rest. And you would have maintenance every 2 years. You would have to need to repaint the whole structure with timber. The first steel dome, there are more than one. The first was built 15 years ago, and up to now, zero maintenance. Because the timber will last longer, doesn't have any problem with corrosion. So you can have timber structure being cheaper than the steel structure. Not always.
But this is pure timber or is it by nature?
It's by nature.
By nature.
Yes. You don't, the timber structure was done without any treatment. It lasts, it's the natural resistance in this case to salt. It would be the same if you have a fertilizer with material inside or other type of humidity. If you have humidity from the salt, from the sea air brings salt and water. It will, if you have a timber structure, if you have a steel structure, you have a corrosion problem, you need to upgrade the steel you are using on your design, and eventually go into stainless steel, and not the lower grade, higher grade. So the price of a steel structure to last the same, it will be much more. And to make a garbage with a steel structure costs more than with a timber. But still it's good for eventually. If you are making a strength building like this and you want to make a truss, then it's a good solution. Every material has their own market, their own use. And what
because to fire because it is timber.
the European standard, when you have a fire, it will burn on the outside. But if you have a fireplace, in your case, you need it, but in Switzerland you need it, and the fire will burn on the outside, but the inside is still below 200 degrees. So the timber structure inside is stable, and the burn creates a cold sharp. It's protecting the temperature inside. So the timber, if we increase the beam in this case for 30 minutes with 2 centimeters more, the width and the height of the beam, we have 30 minutes fire resistance. If we need 60 minutes, we increase for 4.2 centimeters to have the 60 minutes. So the design of the timber structure is feasible for fire resistance. According to European standards, we have to increase for spruce to 0.7 millimeters per minute. That's the 2.1 or 4.2 for 30 or 60 minutes. And this can go up to 120 minutes. Want to touch the spruce?
Software company that create the software for the user in the design space. Actually, we have the 3 area or the theory solution that Autodesk create for user. One is the AEC. It stands for Architectural Engineering and Construction. It's about something like this, starting from the conceptual design, detail design, pre-construction, construction, delivery, and asset management. The second one is the D&M, stand for design and manufacturing. For that one, it's about to create something like this, the mouse, the cars. That is the software for that area. And the third one is the M&E, stand for Multimedia and Entertainment. The software that is very well known is the 3D Studio Max, Maya. But actually we have something more behind the scene. For example, the post-production solution. So the movies, the good one, for example, the Harry Potter or the movie that have the special effect, a lot of them use the Autodesk solution. So this is the 3 solution that we have. In the past, it stayed individually. For example, if we are in the AEC, we may use the 3D Max to do the presentation for the movie, to present my project, right? But we stay in AEC. Manufacturing also just build a car, okay, and that is maybe use 3D Studio Max to present the car. For the movie, also do the movie. But nowadays, all 3 areas is syncs together. That means, for example, once I do already create the design, I can, for example, the facade, I can send the facade model to the manufacturing. If we are talking about the software, that means I can send the facade from Revit to Inventor, and Inventor will create the information and the drawing for the manufacturing or for the fabrication. That means all the information need to go along the way. In the past or now, even nowadays, we have to create something. And if I want to send to another application, I have to find the translator, I have to find some application to translate, right? But for the Autodesk, the workflow back and forth is seamlessly. And nowadays we also have we call the connected BIM. It's the theory that we connect the building information together that everyone can use anywhere, anytime, because all the information stored on cloud. That means what I design is Singapore. This project is in Dubai, so I could share this model on cloud. My colleague in Dubai can open the file and present to the owner in Dubai right away. For the structures, for the MEP mechanical, maybe design in Vietnam, design in Bangkok, but everybody share all the information. It's look like it's very far technology, right? But actually nowadays a lot of designers they already use it. why I know, for example, the project in Bangkok, the one Bangkok, or even the new project, even in Singapore also the same. They start to use the connected beam. Okay, so I would like to show you something about this is a real project. Okay, so we have the rabbit. This is also the same model. I use this model from Reddit. This one is a Naviswork, and the Naviswork they also can share the information with with InfraWork and share the model with the Naviswork. The Naviswork I also can link the information with the project scheduling to do the presentation how I will construct your building. So this is the technology that is changing from 2D to 3D. Actually, it's changed little by little for almost 10 years. But it's because of the technology and the hardware is not powerful enough. But right now, software is okay. Computer is okay. It's time that we start changing our mindset. Also have to find some skill using the tools. And slogan of the Autodesk is make anything. Help you to imagine, use the Autodesk tool, translate into the information that can communicate clearly and can use it for the next step to design and construction and make use, for example, do the assessment. So that is the tools from the Autodesk that will help you guys in each area. No matter you are in AUC, in manufacturing, or even in the entertainment area. For example, the project community mall, starting from zero, using the drone, using the laser scan, the new technology, and start to do the design, conceptual design, have the mapping, have the design road, do the simulation for the car, whether the truck can go in, have the car park, the car park is okay for the SUV or the something like this, and do the presentation using the virtual reality on the other side. So this is all information. Running around, no need to recreate, just use the what you have and go along the way. Okay? I hope that today you will have some information, some inspiration from the tool that Autodesk have. And if you have any questions, please. Any questions?
From BCA digitalization department, okay, in short DG. Okay, so welcome to Build SG, okay, Build SG Pavilion. This is BCA Pavilion. Okay, so just give you some background before you start the tour. Okay, as you may know, the construction industry, okay, traditionally they are working in a silo environment. Architect will do the architect design, they will design the facade, design everything, okay, then they will pass the building model or building design to the civil engineer or mechanical engineer, then plumbing engineer to do the design. Okay, so the civil will make sure the building can stand. Okay, and the mechanical make sure, okay, you have enough icon, okay, your water can go away from the building, you can supply the water to your building. Okay, make sure your building perform. Okay, so all these they are working in a different environment. Okay, so nowadays, okay, because they are hardly to communicate. So once come to the construction stage, okay, the contractor receive everything. They may say, okay, there is a clash between the architect and the structure. So they will ding dong with you have to change. They will arrow. Okay, so nowadays, okay, BCA come up with this concept called IDD, Integrated Digital Delivery Design. So we hope they can using the platform, so we call a CDE, Common Data Environment. They can work together at the early design stage. They will settle everything at the early stage. Okay, so this BCA Pavilion, this year BCA working with around 20 partners. They are from agencies, may have a technology providers. Okay, so demo technology for different stage. So this BCA Pavilion is arranged according to this IDD concept. Okay, we have zone 1 is a design. Okay, start from here is a design. We will demo certain technologies like VR for construction and checking. You can perform a computer checking to check your building whether meet the regulation or not. Okay, then followed by the manufacturer. So we hope the precaster, they will do the precast toilet off the construction site. So then they will deliver this precast come to the set. You will form your building. Okay, then come to construction, and the last one will be FM. And the